Good morning. Let's see this a little bit. How about, can you hear me now? Can you hear me okay like this? Or should I put it closer to me? A bit closer. All right. How about now? One, two, three. How's that? Good? Nope. Cool. Okay. Thank you so much. Thanks for helping with that. My name's Christopher. I lead a project called Giga. We're working with Giga to connect every school and hospital in the world to the internet. And I want to talk about a little bit why that's so important, what it has to do with Ethereum particularly, and what it has to do with blockchain as well. Before I talk about why this is a huge DePIN project and why it's really a coordination problem, I'm going to share with you a little bit about the world that I only learned about 6 years ago, which is a world of lack of connectivity. 1 out of 3 people in the world has no access to the internet, which is a sort of nice abstract number. It doesn't necessarily mean that much. It's hard to understand how you do things, the things that we're all used to when we're, especially so deep in like an ETH Prague conference, if you don't have connectivity. But really fundamentally, this means that if you're a kid in the Amazon rainforest, there's no compute, there's no agentic anything. You're learning from your school stuff that doesn't mean anything to you because it's not even in your local language or idiom. You're far away from a world where you can like have a job or contribute to anything or use GitHub. And that's 1/3 of the world's population. It's like 2 billion people. I built with Aya and the Ethereum Foundation, I built the crypto fund in UNICEF. It was the first crypto-denominated investment or grant-based fund in the public sector. I set up the UNICEF Innovation Unit. And before that, I started a bunch of companies, all looking at how you do technology in emerging markets and how you do it at scale. What I didn't know was how many things weren't connected in the markets I was working in. And I realize now, thinking about it, like maybe there's a reason some of my companies didn't go the way I thought they would, because there's just a lack of fundamental infrastructure. About 1/3 of the world's population isn't connected, but more than half of the world's schools aren't connected. And in particular certain regions, it's much, much more than that. It's like 90%. And I want to ask you to do something. So the last presentation was great because we got pumped up. I want to ask you to take your phones out and just go to a website while I talk. I'd like you to go to our site. It's maps.giga.global. It's going to show you these same maps, but you can see it like in real time on your phone. So if you go to maps.giga.global, G-L-O-B-A-L, you will see these maps and many others. So maps.giga.global is the front end for a lot of the work that we do. It shows you maps of every country in the world. It shows you 40 of those countries with dots on them that have different colors. If you look at the maps on that site, you will see that there are schools. Each dot is a school. The red schools are not connected to the internet. The green schools are. And if you go to Brazil, for example, you can zoom in to Brazil and you can see parts of the country that are much less connected. You can click on one of those schools and you'll see if it's flashing, if it's blinking like that, you'll see how connected it is in real time. Every 4 hours, we get updates. And the reason we do that is we've built the ML to find schools from high-resolution satellite imagery. We do the feature extraction to figure out where schools are. Most countries don't know where their schools are. We've also built the ML to integrate data from the government, from the network operators, who don't always tell the truth about where their network is, from Meta and Google and other creepy platforms, and give you a proximal sense of what's happening in real time. So you can see a country like Thailand, very well connected. A country like Bosnia and Herzegovina, which was so talk about a coordination problem. There's 17 different ministers of education here. So for you to find out what school is doing what was 17 different ministries you had to talk to. But you can see there's sort of some green, some red. A country like Sierra Leone, if you go to it on the map and you zoom into Freetown, you'll see there are like 30 or 40 connected schools in Freetown. Why is it important to have a school that's connected? If you're in one of those red areas, you are not part of the future, you're not part of the present. You just saw yesterday that Dubai bought OpenAI licenses for everybody. Governments are already thinking about how important agentic access is for their populations. If you're in Sierra Leone, which has like, it's the 4th poorest country in the world, you are so far from being able to access a digital surface that you are absolutely left out. And that's a concern for a bunch of reasons. First of all, it's bad for you as the child. You can't contribute your expression, your genius, your beauty to the world. Second, it's bad for the country. So we know that if you connect the schools in Sierra Leone to the level of connectivity in Czech Republic, for example, you raise GDP by like 22%. And that's because you're building infrastructure, but it's also because you're educating people. And then it's bad for the world. If you're disconnected and you're angry, you move somewhere else. You start doing stuff that's not great, and it destabilizes everything. It's also not great for blockchain, because that's a lot of nodes on the network that we don't have access to. So Giga started about 5 years ago working to connect all the schools in the world. We don't do the connection ourselves. We help governments figure out how to do bids. So we just heard in the last presentation from Shutter about RFPs. We do a lot of work with governments and RFPs to make sure they have clear bids for connectivity for schools and health centers. That's all on chain. We also help them do payments for schools. It's not our money, but we help them find the money and manage a treasury to make sure that they can pay schools on time, because underneath this map, there are smart contracts that say when the school is green, you can pay the provider. When the school is red, you don't pay the provider. And we also help governments find the schools in the first place. So in a lot of countries, they don't know where all of their schools are. I'd say almost in every country, there are errors in where locations of schools and health centers are, which sounds crazy because it's 2025, and it's like you think Google Maps and OpenStreetMaps, and we should know the locations. Nobody knows how many schools there are in the world at all. So there's like a baseline kind of denominator problem. We think there are between 5 and 7 million schools, but nobody's ever figured that out exactly. We're doing it. We'll know in the next year or two. In Colombia, the government asked us, well, they gave us their file. They gave us their Excel file, and they're like, here are all of our schools. It's 30,000 schools. We used our satellite mapping and the feature extraction, and we found another 5,000 schools that the government did not have at a national level. Somebody knew where the schools were at a small level, district, region level, but at a national level, they didn't know. And we added, so it's like 15, 17% of the schools. Imagine the inefficiencies in any kind of network design if you don't know where 15% of your stuff is, if your nodes are off that much. In Sudan, we did the school mapping. We found a third of the schools were in the Indian Ocean. This is not, like schools aren't built usually in oceans. There was a problem with the data. Somebody had corrupted the file that they used, their master data file, and it was just off. So we help rectify that, and we help build this network map. As we've been doing this for the past few years, we realized a few things. First of all, it's super expensive to connect schools. So the cost of connecting schools, which means connecting communities, because if the school isn't connected, the community is not well connected, is around $1 trillion. There's about $1 trillion project, between 500 billion and 1.4 trillion. So call it somewhere in the middle. So it costs a lot of money, but it's infrastructure money. It's money to take cables and lay them under the ocean, connect them to the cables in the ground, put up towers, put up masts, maybe put in satellites in some places. So it's investable money. It's money that you can get stuff back from. It's not charity, but it's still big money. And governments are totally unequipped to do this. Like, I don't know who in the room, who's read your internet service provider contract for your home? Anybody? 1, 2, it's maybe like 3, 4 people, right? You know your kind of Mbps and throughput that you're supposed to have? Roughly your downtime, uptime. Okay, so that's like 2 people out of this room. Imagine a government of a country. They're not looking at the service provisions. They don't know the difference between a megabyte and a megabit. They don't understand, uptime, and all of that's new to them. But if you can package it in a way that's accessible, they can start to understand it. And there's a lot of unused infrastructure in the world. So most countries have a lot of fiber that's under the ground that's not being used. So we thought, isn't there a way, since we're putting every school on chain, since each school is an object that you can do stuff with, you can move money to it, move money away from it, couldn't we create some efficiencies if we start to tokenize the gigabyte? And the answer is sort of yes. In countries like Sierra Leone, there is already some infrastructure. Fiber comes into the country through the ocean. So some parts have been built out. And big service providers have connected the wealthy parts of the country. It's just like the William Gibson quote, not evenly distributed, but it's there somewhere. Same for compute, right? Like there's somebody in a research institution who's using T-flops and GPU hours. It's just not pushed out everywhere to the edges of the network. In fact, Most countries have small internet service providers whose job is to do exactly that. Their job is to get connectivity moving more. But they're under-resourced, they're not funded well, or they're funded just to do like their one community and not the rest of the country. And it's hard for them to get loans. It's hard for them to get loans because they're usually 2 or 3 people in one small community, and they've got their little antenna, their access point, they're connecting that community. And this is true in rural Sierra Leone, it's true in rural Thailand. These small internet service providers are the edge of the network. And it's tough for them to integrate with the big network, with the banks. Banks don't want to give them loans, the cost of capital is too high. There's money for infrastructure investment, like you can see in Panama. Like there's money there, the money's in the green areas, it's just not in the red areas. That's because those are the places the banks know about, those are the places the government cares about. There are also large telcos. There's a big phone operator who's making a bucket of money connecting this side. Like this is like a wealthy side. People have big gardens and big pools, and not connecting the poorer area. So there's a telco or utility who's out there doing stuff, but not for the whole country, just for the green area. And there are these small businesses that are ready to hop in if we could motivate them with something. And if they're working on a digital surface, like they're connecting people with gigabytes, isn't crypto a wonderful way to flow some kind of digital currency, digital financing to them, and isn't a blockchain a wonderful way to allow them to be accountable for what they're doing? So we think the answer is yes, obviously. We have 100,000 schools that we have a small appliance that we've built. It's a Chrome appliance that sits in the school. It monitors connectivity, it monitors electricity, it does a bunch of great stuff. It tells us how many gigabytes are flowing through the school, or megabytes, what the throughput is. It tells us whether that school has been connected over time, and it allows us to structure the smart contracts that do payments automatically. And it's all of those dots, if you look at maps.giga.global, it's all those dots that are flashing. The idea that we've been working on and that I want to share with you in the next few minutes is that you can actually use that to trade capacity on these networks. We've built a platform that's being tested in 6 countries, and I'll talk about them in a second, that does 4 things. First of all, it helps small service providers find schools or health centers that they can connect. So it's like imagine an Uber driver trying to find their customer. Service provider looks at the map, they say, here's a place that's disconnected, it's close to me, I can connect it. They kind of make a bid for it. We just heard how important bids are in public procurement, they make a closed bid for it. When they connect it, we help to verify that the thing has actually happened. That's kind of like, Uber says your passenger's in the car, they've been dropped off, and you then get some money for it. So we're able to tokenize the payments to those small service providers and give them money for doing that thing. We're also able to give them the ability to use that connection that we've now proved the Oracle is the school. We've proved that has happened. We allow them to use that token that's been issued to also trade upstream for capacity with the other service providers. So in any country, to get connectivity to a school or a health center in the end of the economic line, you need to go through a bunch of other actors first. And this system of connectivity credits allows us to let a small service provider bid for access upstream to get cheaper access to the rest of the pipeline. Essentially what this allows us to do is to create a framework where the gigabyte access has been tokenized in a way that moves connectivity out of the capitals, it moves capital out of the capitals into the less connected areas. It also creates a sense of liquidity around something that is otherwise a very fixed asset. So gigabytes are not traded regularly. There's an auction once a year, usually in a country, where you kind of bid for your access to throughput. It's not something that's live and dynamic. But here's the thing, a school only uses connectivity for like 4 hours a day. Right? So if you're connecting that school, you should connect it for the 4 hours. You should be able to use the rest of your gigabytes to do other things during the rest of the 24-hour cycle. But right now you can't because it's locked in. However, if you can break it up and fractionalize it as an asset, you can allow that small service provider to delegate their work to other things. So I just wanted to talk about quickly the 4 countries that I have on this deck out of the 6 that we're working in. The other 2 are sort of very, very early stage, where we're building projects. And each one of them I'll sort of tell you a little bit what the problem is, and then also what we're doing there. In South Africa, there's a government service fund that the government has delegated for connecting poor areas. So most countries have this. It's called a universal service fund or a universal access fund. think about it like, I don't know, it's like a foundation treasury that's supposed to make stuff happen and get people using that protocol. The protocol here is the network. Usually the government extracts that money from the service providers, so it's like 2% of the income of the phone operators go into this thing. And like, okay, we know DAOs are kind of sometimes sketchy. This thing isn't a DAO, it's usually controlled by one person, and those are really sketchy. So the money that goes into this universal access fund is like delegated by that one person for whatever they want. That's often not connecting poor areas. South Africa has given us access to this delegated fund. We are able to tokenize it and allocate that money onward to these small service providers and only give it to them once they've shown that they've managed their commitment, that they've connected the school. So in this case, the credit that we're issuing equals money. Service provider gets the credit, they bring it back at the end of the cycle when they've connected the school, they get paid immediately. The fact that they've already locked in the bid for that school allows them also to sometimes get a loan and get some upfront capital. In Kenya, it's a little bit different. In Kenya, most schools are within like 600 to 800 meters of a fiber node. They're just not connected to it. So if you look at the fiber map of Kenya, it's like pretty good. If you look at the school or hospital connectivity map, they're missing that last little bit of connectivity. In Kenya, the credit actually equals capacity on that fiber network. So you're the small ISP. We say, if you connect this school, you get some upstream capacity. You get to put more of your cars on the highway going up, and you can use that capacity to get more people buying your network who aren't schools. So it still equals money, but it just equals money through capacity. In Malawi, Malawi is one of the other 4 or 5 poorest countries in Africa. The fiber equals tax rebates, essentially. The credit equals tax rebates, essentially, or satellite capacity. So we're testing 2 things in Malawi. The government has agreed with us to, they're looking at, let's say, I guess we're being recorded. So it's not official yet, but it's sort of official. They've agreed with us to give a tax discount to companies that connect schools. So if you have the credits for connecting schools, you get a bit of a tax rebate. That's thing 1. Thing 2, we also have the ability to give service providers who connect schools access to some satellite capacity and bandwidth capacity. So there again, you connect the school, health center, you're able to show your credit, you have this on-chain proof of work and or proof of connectivity, and you are able to then get something back for it. And finally, in Mexico, the problem there is that the schools, particularly in Chiapas, are all very small population towns, so it's not worth the large service providers going and putting network up there. Here, again, we're trading credit for capacity on a satellite backhaul. So in each of these cases, we're building this in another 2 countries as well, but in each of these cases, we're trying to see if we can tokenize this asset and create a bit of movement in a much larger, very stuck pool. Where things aren't moving. So nobody's done this last bit of connectivity in the last 15 years. It's like the rates of connectivity are not increasing very well. We think that the market for these small service providers is in the $100 billion to $150 billion range, if they could only have access to capital. And we think that by sort of digitalizing and decentralizing that capital, we give them entry to a market. So we're setting up a small team in Geneva to execute on this. We've got the software running in 40 countries, and in each country, the way that we've managed to make this movement happen is by working with governments, which is really tough to do. So if anybody's spent a lot of time working with the Ministry of Finance or Ministry of ICT, it's a headache. And it doesn't always work super well with like the blockchain-based approach to, build it and figure things out and cypherpunkization of everything. It's hard, and working with governments is hard, but they are the entry point to getting connectivity out to their populations. And so when we work with governments, we also try to help get them up to speed on things that we all take for granted. In Rwanda, we're using staking rewards to pay for school connectivity. It's not a lot of money, but suddenly the government is running 2 nodes. They're able to use a small, it's tiny, we're generating like a few $1,000s a year, that's going to pay for a few schools being connected. But suddenly they see this cycle start where they can understand that digital assets can pay for digital commodities. In other countries, governments are starting to connect the idea of compute to the idea of connectivity. So they know and they understand that if they don't have their country all green on the map, they're going to be sort of seriously at a loss in what's coming. If you go to the map on maps.giga.global and you look at Botswana, you're going to see that all the schools on the bottom of it in the south part of the country are green. All the schools on the north part are red. There are a few that are turning green now because they've been connected. And I was talking to the president of the country, President Masisi, about 6, 7 months ago, and he said, Botswana's always been a landlocked country, but we think that digital is the new ocean, and we think that schools and communities that are connected are the ports on that ocean, which will allow us to trade things globally. And we need our people to be able to access those ports. And to me, this comes down to the fundamental thing that all of us are trying to do, I think, which is to create a better, stronger network, an open network for access around the world. And so I'm delighted to be able to present this to you. The foundation, which will be the Connectivity and Compute Foundation, will be launched in Geneva over the coming months. It's supported by Giga, it's supported by the work that we're doing, and many in this community as well. And I'm delighted to have a few minutes also to answer any questions about connectivity, schools, health centers, and how we can make the world a little bit more able to transact a little bit more fairly by looking at emerging markets and looking at the technologies we care about so deeply. Thank you very much.
Hi, thanks for the talk. That was very interesting. Very nice to hear about also UNICEF Innovation Finance, seeing that around. One thing is obviously you go through the governments and you have this privileged position that as UNICEF you have a very good brand and very good working relationship with ministries. But a lot of people want to help, loads of foundations will not have that. How do you see a timeline or any hope to be able to go with, let's say, stablecoins directly to the communities without having to go through government, which then obviously would be much more sustainable politically, I guess. Thank you.
So Aya and I will be talking about this at 12 o'clock right here. Come back for more. But I think you can do, without the governments, I think you can go to the green areas. So I think you can get stable coins out to the places that are green. So amazing. I was talking to a friend of mine in Kyrgyzstan the other day, and he's like, I was just out with these rural farmers, and they're getting remittances. And I was like, oh, what are they using for it? He's like, Bitcoin. And I'm like, that's amazing. That's crazy to me, right? That's what they chose for rural farmers getting $7 in remittances. It works in the green areas, but it's going to be really hard to get the stuff we care about into those disconnected areas if we don't go through governments. I don't know any other way to solve it. They're the gatekeepers to the disconnected areas. And so I think that we can do a bunch and we can feel good about it because we're going to be like, great, our protocol has 100% adoption in part of the country. But to get it to these disconnected areas, it's going to take a lot of work, and working with governments is a pain and it's hard to do, but I don't think you can break through some of these barriers without them. And so what I'd encourage anybody to do is come and collaborate with us. I mean, Giga is sort of on the edge of UNICEF, and then we have other things that are even further on the edge. Come and work with us because we can be the API into that, and we do it. We work with a lot of different protocols and try to help guide things and make the relationship with government work.
Hello, thank you for the talk. It was really, it's a great initiative, and the map is amazing. I was just curious, why isn't there Czech Republic connected in the map? It's literally the whole Europe is blinking and there's points, but the Czech Republic is just black.
So if you look at the map, Europe is blue. Blue dots don't count. So blue dots are where we've just grabbed the school location from the satellite data. We are the largest contributor right now to OpenStreetMaps of anybody. So we send the most data to OpenStreetMaps. So blue, we've just mapped the location of the school. It's only the 40 countries where you see red and yellow and green that we've actually put our software into play in the country. So look at Mongolia, all 800 schools in Mongolia have our software in it. In Europe, we haven't had the government request us to do the mapping yet. I'm working on it. So I'm in Switzerland. Our team is also in Barcelona. We're working with Switzerland and Spain. I'd love Czech Republic to do it. But somebody in the Ministry of Finance or Ministry of Education has to say yes to this. Otherwise, we can't, we have the data, but I can't really put it online because we'll get shut down. So it goes back to this question of working with governments. I would say check back in 6 months on Czech Republic. We might have, check back in 8 months. let's see what happens with the new government.
I have a question. So how do you convince governments? Like, what do governments get out of this?
I usually show that map to the head of state, to the president or prime minister, and I'm like, look at your country, look at all the red stuff. And they're like, why is it all red? And I'm like, I don't know, it's your country. Let's figure it out together. But I find that if you go to that top person and you show them a map and you show them a bunch of red schools on it, it freaks them out because they know that those parts of the population are going to be left out, they're going to be angry, they're going to want to change regime, whatever, and they're not going to have the same outcomes as other parts of the country. So I showed it to President Kagame in Rwanda, that was the first president, but every head of state or prime minister reacts like that to it. So you start at the top. It's hard to have that access, and not even UNICEF gives you that. I mean, that you have to sort of earn that. But governments work on precedent. So once you infect one, they start infecting the others. And then you get government, presidents and others coming to you and being like, what's that thing you did for our neighbor? I heard that you made the map for them. And so, but it's honestly that. It's if you show the data, if you show the node disparity, you can get a policymaker to open some doors and make things happen. The other thing is we work with local developers on stuff. So all of this, it's all open source, obviously, but it's also built in countries by their own developers, so they have somebody who manages it. It's not a bunch of people outside. So I think those are the two levels.
If you need help with India, let me know. I have some.
We need a ton of help with India because the regulation allows us to look at the data but not to change it. So there's a very specific legal framework for reposting. We have all the school locations, 1 million some schools, but we're stuck on a regulatory part. So happy to chat with you after. Cool. Thank you very much.